Hello, in this video we study how to find volumes of the solid regions with no cross sections. So what is that? Let's look at this method and even the washer methods, right? But let's talk about this method first. You have some region, right? And you rotate about the x-axis. You have some solid, is that correct? And you see, yeah, the formula is v equal to pi integral from a to b. This is a, this is b, f of x square dx. Why? Why do we have this formula? I think we discussed this very detailed, right, when we study this. So usually I will consider some delta x in here. Is that correct? And you have some disk like this. And this is what? That is the function value at this point, right? So I have rectangular in here. This is y equal to f of x. And, we need to find actually what is pi f of x square. Pi fx square is the area function. Is the area function, right? And that is the area of what? Of the circle. Of the circle. Radius equal to f of x. So if you fix some x in here, right? So you have a circle. That's all right. Yeah, let's move this to here. You have a circle like this. Is that correct? You have a disk, right? And in order to find, the area of that circle, so that is just pi f of x square, pi r square. That's why you have pi f of x square. And then when you move this circle along the x-axis, right, on the interval a and b, you have integral from a to b, pi of fx square. So that's why you have, this formula. Does that make sense? So if you rotate about the y-axis, you use almost the same idea, right? You have this guy. This is the y-axis. And so, the cross-section should be perpendicular to the axis of rotation. And again, in here, you just see that. But actually, you have some, this like this. And the formula is v equal to pi from c to d f of y square dy. And again, what is pi f of y? That is the area of this circle. You see? So basically, in order to find the volume, we need to find the cross, right? The cross section, and then we integrate the area function on some interval. Is it correct? So that is the whole idea. So, of course, the disk method and the wash method can be applied when you have solids obtained by revolving some region and plane region, right? About the x or the y axis. Now, let's say we have solids, right? We know the cross sections, but those solids are not obtained by revolving a region about the x or the y axis. So how to find volume of such solids? That is the main purpose of today's video. Okay, so let's consider the following example. Let's find the volume of the solid described as follows. The base of the solid is the region bounded by the lines. So that solid is parameter, okay? So the base is the region bounded by the lines f of x equal to 1 minus x over 2. G is negative 1 plus x over 2 and x equal to 0. That is the first. The second one, the cross sections perpendicular to the x-axis are equilateral triangles. So you have the following picture. So this is the y, okay? This is the x, and of course we still have the z right here, okay? Let me describe that. Here you have negative 1, here you have 1, here you have 2, and here you have some numbers, right? We will find that out. So we have parameter, that is, one straight line. This is another straight line, as you have seen here. The first one is 1 minus x over 2. The second one is negative 1 plus x over 2. So your function g is right here. The function f is right here. Okay, so this point, the intersection between these two guys, we need to find that out, and actually that is 2. We'll show that later. Okay, so we have another vertex. Let me see, there's another vertex in here. So you have parameter, and then I connect all these together. Okay, so the base is triangle in here, and the cross sections perpendicular to the x-axis are equilateral triangles. So what is that? So that means if you have some cut in here, if you have some cut at some x right here, right? So you will have this, and this is your the section, the cross section perpendicular to the x-axis, and that is equilateral triangles. So you have equilateral triangles in here. Okay, so we need to figure it out, this coordinate. Firstly, we need to find the intersection. Why we have 2 right here? Okay, why do we have 2 right there? Because when you put f and g equals, right, you have 1 minus x over 2 equal to negative 1 plus x over 2. You solve for the x, you have 2 equal to x, right? Because you bring this term into this side with a negative, right? So you change to positive. X over 2 plus x over 2 is just x. Negative 1 with the 1, but you change the sign, so you have 1 plus 1 is 2. All right, so the intersection is x equal to 2. Now, similar to the case of this method, we need to find the area of the cross section. So our cross section is this, right? We need to find the area of this, and we know that is equilateral triangle. So we need to find just one side of that triangle, right? Because that is 3 sides are equal. So suppose that if you have some x in here, okay, some x in here, you need to find the length of this guy. Is it correct? So let's look at the picture on the xy plane. So you have xy plane in here. Okay, this is y, this is x. Let's say you have 1 in here, and here you have negative 1, and here you have 2. You see? So this is your triangle. So you have x, some x in here. You need to find this interval. Okay, means the length of that interval. And we know the equation of this straight line. You see? So in order to find this distance, we just plug x into the equation of this straight line. But what is the straight line right here? That is the y equal to f of x, right? Where is y equal to f of x? That is 1 minus x over 2. So I can see, yeah, if we have x in here, here should be 1 minus x over 2. And that is the y coordinate, right? That is the distance, a half of that interval. So I can find the base, right? The size of this is equal to 2 times 1 minus x over 2, which is 2 minus x. So that is the length of each side of our equilateral triangle. You have triangle, right? And each is, 2 minus x. Of course, we know how to find the area of such triangle. Okay, the area of this is nothing but equal to 1/2. Let's say product of 2 minus x times 2 minus x, and then times sine of 60 degree. Okay, so sine of 60 degree is square root of 3 over 2 times 1 over 2. In here I have 2 minus x squared. So the area is square root of 3 over 4 2 minus x squared. And that is the area of the cross section right here. Right here. Okay, and now if you move these cross sections along the x-axis from 0 to 2, right, you have the volume of that solid. So I can write here the volume is equal to integral from 0 to 2. The area function is square root of 3 over 4 2 minus, oh my goodness, I do a mistake in here. Here should not 2 minus x, should be 2 minus x squared right here. X squared and then dx. Okay, so you can do substitution, but I think we can integrate this function right away. Square 3 over 4, just coefficient, I can rewrite as x minus 2 squared dx, because under the square, x minus 2 or 2 minus x is the same, right? And you have square root 3 over 4, antiderivative of this is x minus 2 cubed over 3, evaluated from 0 to 2. So you just plug 0 and 2 into the function, you get square root 3 over 4. Add 2, the function is 0. So I write 0 in here minus 0 minus 2 square cube over 3. And you simplify this, you get 2 square root 3 over 3. And that is the volume of our solid. You see, it's pretty easy, right? And again, if we write the formula in general form, right? If we know the cross section, and we know the area function of the cross section at some point x right here, you can write the volume formula. Okay, let's write it down. If you have the area function ax, and you know the interval, that is a and b, then you just evaluate the integral of that area function, you get the volume. That's what we see in this example. All right, so that is very general idea, and I tell you again, right, this idea works almost everywhere in this course, in this chapter, when you need to evaluate integrals. So you need to consider the cross sections all the time. Okay, even you have this method and then wash method, and maybe in the future you study the shell method, you also need to consider the cross sections, right?